All right, so we are going to finish up writing equations of a line, and we've been focusing on one equation only, and that is the slope-intercept form. It's really the most user-friendly, especially when you're graphing. We talked a little bit about the standard form. We graphed using the intercepts, and we have really not talked anything about what's called the point-slope form. And it's exactly how it's named. You need a point and a slope, and you're going to leave it in this form right here. So let's look at a few examples of this, and then we'll talk about the other ones. We're not going to talk too much about slope-intercept because that's all we've been doing. Okay, so again, here is the form. It's y minus y1 equals mx minus x1. Okay. Now, if you'll notice here, we have our x and our y and our m. So all you're going to do is you're going to plug everything in. Again, there's my x1, my y1, and my m. So it's as easy as plugging the y1 in, which is 5, the slope, which is -1/5, and then the last thing you're going to plug in is x1, which is -5. Now here's the thing, if I plug a -5 into a -5, so if I plug a -5 into there, right, like you see, it's actually just going to turn this positive, right? So our final answer would be 1/5 x plus 5. Okay? And you're done if they want you to leave it in the point slope form. Okay? So let's look at the next one. There's your x1, there's your y1, and there is your m. Okay? So we are going to go ahead and we are going to plug in my y1, which is 3, my slope, which is 4, and then my x1, which is 1, and we're done. Okay. Now, some people like this form because it's pretty easy to set up. However, if you were to graph this, you really need it in the slope-intercept form. So we're going to take a look at that now. What we're going to do is we're going to have it in this form. And if you look at problems 3 and 4, we're going to have it in the point-slope form. And we're going to put it into the slope-intercept form. Really, a lot of times you want to do this if you had to graph this again, okay? So let's take a look at this. Okay, so number 3 wants us to put it into slope intercept. So your job really is to take the equation and solve for y, or get y by itself. Well, if you're going to follow the order of operation, I believe the first thing you'd want to do here is distribute your -2x, which is the slope, remember, which is going to make this -4, right? -2 and 2. Now, all you're going to do is one more move, because I want to get y by itself, is I'm going to get rid of the 1 by adding it. I'm going to add it to the -4 to group like terms. And now you'll notice, well, negative 4 and 1 is what? Negative 3. And you're done. Again, a lot of people do this because they rather graph in this form. All right, so let's take a look at this one now. All right, so we're going to distribute the 6 over 5x, so that would be 6 over 5x, times, well, 6 over 5 times negative 5. The 5's would cancel out, wouldn't they? And you'd be left with a negative 6. And then I am going to remove the 3 by adding it. Okay. And you'll notice you have 6 over 5x, which represents my slope. Negative 6, positive 3 is negative 3. And you could go ahead and graph that if you needed to, okay? All right, now the last form is standard form. And okay, last is what we're going to call standard form here. Couple things about standard form. A, B, we have to have integers for all of these. We can't have any fractions, okay? So everything has to be an integer. And A cannot be negative, all right? And it says A, B, and C have to have a common factor of 1. Just means it has to be reduced, okay? So, if you look at this one here, you're really just getting the constant by itself. Well, you'll notice there's no fractions, okay? So basically, if I took the 3x and I moved it over to the other side, I would have to subtract it, right? Wouldn't I have to subtract 3x to get it over there? Right, so if I'm going to subtract 3x, I have negative 3x. That's a positive y equals 2. All right. Now, I'm almost there. The only thing is it says that A cannot be negative. If you'll notice in here, A is negative 3. So to get rid of that, all I'm going to do is multiply everything by negative 1, which is a common rule. It's the identity rule. You're allowed to do that. So I'm going to multiply everything by negative 1. So that would be 3x, right? Times negative y equals negative 2. All right, now you've followed all the rules, okay? There's no fractions. And you're done. All right. Next problem. I notice is a fraction. So I know that A, B, and I know that I can't have any fractions in my problem. So what I'm going to do is I'm going to get rid of the fraction right away. And by doing that is I multiply everything by the common denominator. We did that when we did equations, okay? So I'm going to multiply everything by 6. So I have 6 times y would be 6y. And then I'm going to have 6 times negative 11 over 6. So the 6's would cancel. And I'd be left with a negative 11x. And don't forget to do the last one. So 6 times negative 6 would be negative 36. Okay. Now my job is to go ahead and move this over to the other side because I want the x's and the y on one side. So to get rid of a negative 11, I'm going to add 11x plus 6y equals a negative 36. Okay, so again, how I did that is I moved that over, excuse me, by adding it, right? Now I'm done. A is not negative. I have nothing in common for any of these, so I'm done.